All right, so now we're back and we're going to talk a little bit more about histograms. There were a lot of questions about these in the first week, and so I just want to come back to them, and I think it will really help us as we move forward. So a histogram is a type of graph, and it shows you how frequently certain values show up in your data set. And so here you can see just a basic histogram showing the value of the variable on X and the frequency of the observations on Y. Now, according to this histogram, we would say that the mode is 7, okay? Because 7 is the number that shows up most frequently. Now, for this data set, I don't know what the average is. I would actually have to count up all of the values and divide by the total number of values in the data set. So it doesn't show me the average. And in terms of the median, it also doesn't show me the median because I would need to line up all of these values and find the middle value. And that might not be the same as the mode, but you can get the mode very quickly from a histogram. So sometimes the shape of the histogram can tell us something. So what about this one? Whoa, this one is called a bimodal histogram. It has two modes. So a value somewhere around, like I would say 51 is one of the modes, and a value around somewhere like 68 is the second mode. Okay, so a bimodal histogram tells you that something's going on where the data are kind of converging around two separate points. And so this can show you some kind of interesting things about your data. Most of the time, you don't end up with a bimodal situation, but it does happen occasionally. So I'm going to basically smooth out the jaggedy edges of the histogram and just show you some other shapes, or actually I'm not going to do that quite yet, but I'm going to show you some other shapes. So here in the top right, you can see that bimodal shape where it's kind of got like two humps. There's one kind of camel with one hump, right? And one kind of camel with two humps. So maybe that'll help you figure or like remember this. So if you're the type of camel with one hump and the hump is right in the middle of the histogram, then it's a bell-shaped curve. And this is really common type of data distribution in statistics. So we'll come back to this one a lot. The bimodal is another one that's on the top right. And then you can have data that are skewed either to the right or to the left. And so that's an interesting type of distribution to have some kind of skew. We'll talk about an example that might make some sense to you that's skewed. J-shaped just means that there's like 0. Maybe there's a lot of zeros in your data set, and then you have some big values. So you can have data that's limited on one side by something. And you can have a U-shaped or you can have a uniform histogram. So the shape of the data set tells you something about like what the central tendency is. It tells you about how variable it is if it's got really long tails on either side. And these distributions are used really frequently in statistics. So when the data are normally distributed with a bell curve, then something really cool occurs, and that is that the mean and the median are the same. Okay, so and sometimes the mode, the mean, the median, and the mode are all the same in a bell-shaped curve. And they're all that value right at the very top of the curve. And this is, I think, why the bell-shaped curve is one of the most commonly sought and used distributions in statistics. Okay, but data aren't always normally distributed. So take the mean household income for the US, and this was from the 2015 survey. So it may have changed, or it's in the process of being changed now because we're in the middle of another survey. And what you can see is that it's very skewed. It's skewed toward the poor, right? There are more people who are poor in the US, and there are very few people that are very wealthy. And so this is why we often talk about the median income instead of the mean, because if there are a few people that are skewed and make a lot of money, that's going to drive the mean income up quite a lot and make it seem like Americans are more wealthy on average. But that's not really true. A better measure of central tendency in terms of income is where's the middle person in America, right? That's the median income. And you can see that there's a $20,000 difference between the mean income and the median income. And this is because there are a few very, very wealthy individuals that drive the mean income up. Okay. So these are really useful in terms of understanding social systems and economics. And statistics is used all over the place, right? Okay, graphing basics. We're just going to briefly go a little bit further into graphing. Of course, you need to know what kind of variable you have, continuous, categorical, ordinal. You need to know that your independent variable goes on the x-axis and that your dependent or response variable goes on the y-axis. So again, most of the time we're dealing with y values. That's why we're talking about y bar as our statistic. And then your x-axis might be a categorical variable. It might be a continuous variable. So in this case, here's an example graph where you have species diversity of, let's say this was aquatic insects in two different streams, Snyder Cove Creek and Barking Dog Creek. These are two streams on campus. And in this case, the X variable is categorical. Okay, are you this stream or that stream? And the Y variable is continuous. It's some measure of how diverse is the community that we find in these streams. And you can see the bars are slightly different. Okay, so the bar represents the mean in this case. You can see it looks like there's slightly more higher diversity in Snyder Cove Creek than Barking Dog Creek. But there's also some variation around the mean, and this is what we're going to talk about next week. So the error bars tell you how kind of confident you are in that mean. And in this case, we're not super confident about the mean. And in fact, the error bars overlap. And if we ran a statistical test, it would actually tell us that there's not a significant difference between the diversity in Snyder Creek and Barking Dog Creek. So the mean gets you there, gets you partway there. But then there's some real important information in the variation around the mean too. And this will all become more clear as we go through the program. But just as an example, I'm going to show you a graph that does show a significant difference. And I just want to say, note that there are axis labels. Okay, it says stream on the x-axis, and then it's labeled as either Snyder Cove or Barking Dog Creek. And then it says species diversity on the y-axis. This is not a default setting in Excel. I do not know why, but you might have to add axis labels to your graphs. Here is an example that shows a strong significant difference. So now we can see the means are much further apart and the error bars are also not overlapping. And so in this case, we could say, oh, actually, maybe this is algae or something. Barking Dog Creek has a much higher diversity of algae than Snyder Cove Creek. Okay, so again, categorical X variables and a continuous Y variable. And one little joke. Should we scare the opposition by announcing our mean height or lull them by announcing our median height? Huh? Well, I'm full of really bad statistics jokes, so you can either ignore me or you can laugh along. All right, see you in the next lecture.